In this video, we review every details about the quadratic function. We learn how to find zeros of quadratic function by factoring or by quadratic formula. We solve some inequality contain quadratic function, how to find vertex, axis of symmetry, x-intercept, and all details about the quadratic function. First, let's start by definition of quadratic function. A quadratic function has a standard form of ax squared plus bx plus c when a, b, c are real number and a is non-zero. Because if a is 0, then we don't have the first term and remaining part bx plus c is a linear function. Quadratic formula is in the form of negative b plus and minus the square root of b squared minus 4ac divided by 2a. b squared minus 4ac, we call it discriminant. And it's really important and shows us if the quadratic equation has two real zero or one real zero or no real zero. If discriminant b squared minus 4ac is a positive constant, then we can conclude that there are two real zero. If it's equals to 0, there is one real zero. And if it's negative, then there is no real zero. When we look at the equation, coefficient of x squared, which is a, tells us if this quadratic equation that it's a parabola shape, it opens up or down. If a is positive, then the parabola opens up. And when a parabola opens up, there is a minimum point. When a is negative, the parabola opens down. And then there is a maximum point. Now I want to go over some questions, and during solving the questions, I tell you how you can find max or minimum point, that we call it vertex, how we can find axis of symmetry, and find the maximum or minimum value for a quadratic function. The first question, we have a quadratic equation g of x, 2x squared minus 5x minus 3, and we want to find x-intercepts by factoring. When the question asks about x-intercepts or zeros of equation, roots of function, all of these have the same meanings. It means we are looking for intersection of function with the x-axis. To find intersection of function with x-axis, we set y equals 0. Y or our function. Here the function is g of x, so we set it to 0. Now we have this equation, 2x squared minus 5x minus 3 equals to 0. We want to solve it by factoring because the coefficient of x squared is not 1. The first step here is to multiply 2 by negative 3. 2 times negative 3 is negative 6. Now I'm looking for two constant with multiplication negative 6 and their addition negative 5, because negative 5 is the constant coefficient of x. Now, what is a and b? Because multiplication is negative, it means that one of the values is positive, the other one is negative. The addition is negative 5, it means the greater value is negative. So positive 1 and negative 6. Now we need to rewrite the function. 2x squared, instead of negative 5x, I'm going to write 1x minus 6x. Now we factor by grouping. If you look at the first two terms, you see that the common factor is x. And by looking at the next two terms, you see that the common factor is negative 3, because negative 6 is negative 3 times 2. So let's factor by grouping. Now we have x times 2x plus 1 and negative 3 times 2x plus 1. You see that there is common factor 2x plus 1 between the first and second term. Let's factor 2x plus 1. The remaining part from the first term is x, and from the second is negative 3. Multiplication of two sentences is 0. So first one is 0 or second one is 0. If first one is 0, then 2x is negative 1 and x is negative 1/2. If x minus 3 is 0, then x is 3. Now, x equals negative 1/2 and x equals 3 are x-intercept for this function. We call them x-intercept, real zeros, roots of a function, and all these have the same meaning. Again, we have a function x times x plus 11 plus 18, and we are looking for x-intercepts. We want to find x-intercepts or zeros of this function by factoring. This is a quadratic equation. If you distribute x to the parentheses, you see x squared plus 11x plus 18. Now, because the coefficient of x squared is 1, we are looking for two constant multiplication, positive 18, and their addition, positive 11. Because multiplication is positive, there are two situations, maybe both are positive or both are negative. But because addition is positive, both should be positive. So those values are 2 and 9. And we are looking for 0. It means that we set g of x to 0. Those values, as I said, it's positive 2 and positive 9. So I can write it as x plus 2 times x plus 9 is 0. It means x plus 2 is 0 and x is negative 2, or x plus 9 is 0, and x is negative 9. Now, these two constants are x-intercepts, or real zeros for this function. In the next question, again we have a quadratic function, the square of 2x plus 3 minus 32, and we want to find zeros by square root method. So because we are looking for zeros, it means that f of x is 0. So we have square of 2x plus 3 minus 32 is 0. The square root method says that when you have a square of x minus a equals to, for example, h, then take square root from both sides, and x minus a is positive and negative square root of h. Then you can add a to both sides, and x is positive and negative square root of h plus a. Here, to use the square root method, I keep the square term in one side, so we add 32 to both sides. 32 is the square of 2x plus 3. The next step is to get rid of a square. So we can take a square root from both sides. The square root of 32, and in the right hand side we take a square root of 2x plus 3, which is positive and negative 2x plus 3. I prefer to put positive and negative sign here because it's more easy to deal. Now we have two equations. One of them is 2x plus 3 equals to square root of 32, and the other one is 2x plus 3 minus square root of 32. Let's solve one by one. We subtract 3 at the first step, and then we divide by the coefficient of x. So x is square root of 32 half minus 3 half. If it's possible, then we simplify square root of 32. We know that it is possible to simplify square root of 32, so let's simplify this way. We know that 32 actually is 2 to the power 5. So I can rewrite it as 2 to the power 4 times 2 to the power 1. So square root of 32 actually is square root of 2 to the power 4 times 2 to the power 1. Square root of 2 to 4 is 2 squared, and 2 to the power 1 stands under the square root. So actually it's 4 times the square root of 2. So x is 4 times the square root of 2 half minus 3 half, and I can write it as 2 square root of 2 minus 3 half. This is one of the real zeros. Now let's solve the second equation. 2x plus 3 is negative square root of 32. Again, we subtract 3 from both sides, so we have negative square root of 32 minus 3. We divide by 2, so it's negative square root of 32 half minus 3 half. And again, we substitute square root of 32 by 4 times the square root of 2, and if I divide by denominator, then we have negative 2 square root of 2 minus 3 half. Don't forget that we cannot simplify more because this term is not similar to 3 half or 1.5. In the next question, again we have a quadratic function and we want to find zeros by using the quadratic formula. So let's recall that quadratic formula is x equals negative b plus and minus the square root of b squared minus 4ac divided by 2 times a. A is coefficient of x squared, so it's positive 5. B is coefficient of x, so it's positive 14. And C is constant, so it's positive 8. Now, at this step, we want to just replace A, B, C by 5, 14, and 8. Now we need to simplify. So x is negative 14 plus 6 over 10, or negative 14 minus 6 over 10. There are two real zeros, negative 14 plus 6 over 10, or negative 8 over 10. And the other one, it's negative 14 minus 6 over 10, or negative 20 over 10, which is negative 2. And these two are real zeros for this quadratic equation, or x-intercept. Now we have two quadratic equations, f and g, and we want to solve equation of f equals g. To solve this equation, we set f equals g. X squared minus x plus 3 should be equals to 2x squared minus 3x minus 60. If we had a graphing calculator to solve this equation, we could graph f and g and then see what are the intersection between these two graphs. Then the x value of intersection are solution for this equation. But right now we want to solve it algebraically. The first step is to put everything in one side and set the equation to 0. So I'm going to subtract 2x squared from both sides, add 3x to both sides, and positive 60. Now we can solve this quadratic equation by any method that we want, by factoring or quadratic formula or completing the square, any method. I want to use factoring. I prefer to multiply equation by -1. So I have x squared minus 2x minus 63 is 0. Now we are looking for two constants with multiplication -63. So one of them should be positive, the other one should be negative. And their addition is -2. It means the greater value, the larger one, should be negative, and those two values can be -9 and +7. So we have x minus 9 times x plus 7 is 0. Multiplication of two terms are 0. So the first one can be 0 and x is 9. If second one is 0, then x is negative 7. Now x equals 9 and x equals to negative 7 are two intersections of f and g. It means that if you sketch the graph of these two parabola, you see that the intersection happen at x equals negative 7 and x equals positive 9. For the next question, we have p of x, x to power 4 minus 6x squared minus 72. As you see, the function is not quadratic anymore. We are looking for real zeros or x-intercepts of this function. The function is not quadratic, but it is quadratic in form equation. By quadratic in form equation, I mean that equation is like a u squared plus b u plus c. And as you see, I didn't use ax squared plus bx plus c anymore. And here u is a function based on x. For example, u can be x minus 1, 2x, the square root of x minus 1, or any function. Because we are looking for zeros, we set function to 0 at the first step. Now we want to rewrite the equation to see u squared and u instead of x to power 4 and x squared. I can rewrite x to power 4 as a square of x squared. And here we have x squared minus 72. Now you see I have u squared minus 6u minus 72. So if I set x squared as u and rewrite my equation in terms of u, you see that it's u squared minus 6u minus 72. Now it is a quadratic equation, and you can solve it by any method that you want, by factoring, completing the square, or quadratic formula. So let's use factoring to solve this equation. We are looking for two constant, multiplication negative 72 and their addition negative 6. Because multiplication is negative, one of them is negative, the other one is positive. Addition is negative, so the larger one should be negative. We know that negative 12 times positive 6 is negative 72, and addition of negative 12 and positive 6 is negative 6. So we have multiplication of these two terms, u minus 12 and u plus 6 is 0. Multiplication is negative, it's 0. It means that u minus 12 is 0 and u is 12, or u plus 6 is 0 and u is negative 6. But keep in mind that when we have quadratic in form equation, u, it's not the final answer, because we rewrite our equation in terms of u. So we need to back to the original variable of our function. It means x squared. We know that u is x squared. So right now, 12, it's equals to x squared. To find x, we need to take a square root from both sides. So x is positive and negative, square root of 12, and x squared is negative 6. And here, you know that we cannot take a square root to find a real zero. If we take a square root, then here x is positive and negative. Square root of negative 6, we know it's not real, but it can be imaginary 0. If we are looking for imaginary 0 as well, or complex 0, then it's positive and negative I times square root of 6. But this equation has two real zeros and two complex zeros. Positive I square root of 6 and negative I square root of 6. The next question, we have a function. As you see, it's not quadratic. X plus 5 square root of x minus 6, and we are looking for real zeros for this function. Because we are looking for zeros or x-intercept, definitely the first step is to set the function to 0. How we can solve this equation? Actually, this equation is quadratic in form equation, because here we have x to power 1/2, and here we have x to power 1. In a quadratic in form equation, actually it's au squared plus bu plus c. This is the function. And exponent of u is 1 and 2. As you see, if we multiply 1 by 2, we get this exponent. If you have a function and the function has this property, it means that you have a variable to exponent 1 or any exponent. Let's call it, for example, I, and here you see 2i, then it is a quadratic in form equation. Now, if I rewrite the equation in this way, you can easily see that we have x to power 1/2 and 1/2. Let's suppose it's I, and here you have 2 times 1/2, which is 1. So this is a quadratic in form equation. So when we have a quadratic in form equation, x to power 1/2 or u is a new variable. So we set u x to power 1/2. And if u is x to power 1/2, then x is u squared. Now let's rewrite the equation. U squared plus 5 times u minus 6 is 0. Again, we have a quadratic equation and we can solve it by any method that we want. If we can find two constants with multiplication -6 and addition +5, we can solve it by factoring. So two constants, one of them is positive, the other one is negative. Multiplication is -6 and addition is +5. One of them is +6, the other one is -1. U plus 6 times u minus 1 is 0. So we conclude u plus 6 is 0 and u is negative 6. U is negative 6. It means that x to power 1/2 is negative 6. Or the square root of x is negative 6. And the other one, u minus 1 is 0. It means u is 1, or the square root of x is 1. Now we are looking for x. Okay, if the square root of x is negative 6, then we know that the square root of x at least is 0. So it cannot be a negative constant. So there is no x. There is no real x from this equation. And from the second one, the square root of x is 1. To find x, we take a square from both sides, and a square root of x is square of 1, so x is 1. For the next question, we have a quadratic equation. We want to find zeros, vertex, axis of symmetry, x-intercept, y-intercept, and then find if the function has minimum or maximum value. So let's start by finding the zeros of this quadratic equation. We set the function to 0. Negative 2x squared plus 2x minus 1 is 0. Let's solve it by quadratic formula. A is coefficient of x squared, b is coefficient of x, and c is constant. And x is negative b plus and minus the square root of b squared minus 4ac divided by 2a. So we plug negative 2, 2, and negative 1 instead of a, b, and c. And we have this one. If we simplify, then we have negative 2 plus and minus the square root of negative 4 divided by negative 4. Under the square root is negative. It means that there is no real zero for this quadratic equation. There is complex zero. And I can write it as I square root of 4. And the square root of 4 is 2. So we can write it as 2i over negative 4. We can divide numerator and denominator by negative 2. Then x is 1 minus I half, or 1 plus I half. As you see, it is a complex zero. It's not real zero. What is the vertex? To find the vertex for a quadratic equation, x of vertex is negative b divided by 2a. So it's negative 2 divided by 2 times negative 2, which is positive 1/2. And y value of vertex, it's f of x of vertex. So it's f of 1/2. So we plug 1/2 in the function, simplify to find the final answer, and as you see, it's equals to negative 1/2. So vertex is 1/2 and negative 1/2. To find the axis of symmetry, we know that it is a vertical line for a parabola, so it's x equals x of vertex. And x of vertex is 1, half. So x equals 1/2 is the axis of symmetry. We know that there is no real zero. When there is no real zero, it means that when you sketch the graph of function, there is no intersection between function and x-axis. There is no intersection, okay? So if there is no intersection and the function has minimum, then let me sketch the graph of function. When we have a parabola opens down, if I sketch the parabola like this, you see there is real zero. If I sketch it like this, again, there is real zero. How about if I sketch this way? There is no intersection with x-axis anymore. So if a parabola opens down and it has no real zero, never has any intersection with the x-axis, and always should be under the x-axis, f of x always is negative and never is positive. We already know what is the vertex is 1/2 and -1/2. So vertex is here. When we have the vertex, then we know what is the axis of symmetry, right? This is the axis of symmetry. X equals to 1/2. It's a vertical line. Suppose this is a vertical line. And y-intercept is -1. So here it's y-intercept. Vertex is the maximum point, and the parabola opens down and it's symmetric respect to the x equals to 1/2. So this is the parabola that we are looking for. As you see, there is no intersection with the x-axis, and the graph of function for all real number is under the x-axis. So what's the answer to this inequality? For which value of x, f of x is negative? As you see, it doesn't matter what is the amount of x, always the function is under the x-axis. So the answer is from -infinity to +infinity. How about this one? For which value of x our function is above x-axis? The function is not above x-axis. So what's the answer? It's empty set. You can show it either way. Overall, if you have a parabola that opens, for example, up, then and it has two real zeros, like these 2 points, to x-intercept, then to answer the inequality, when it asks about for which value of x the function is positive, it means it's above x-axis. And when it asks for which value of x is under the x-axis, f of x is negative. Okay, when the function is positive, it includes these points, right? What we know about the x value of these points? We know that the x values are greater than b. These points have x values less than a. So if the question asks what are the x values that f of x is positive, f of x is positive, it means above x-axis, your answer is this: from -infinity to a, from b to +infinity. And when it asks about the negative y value or negative f of x, it includes these points, and you see that the x value of these points are between a and b. The next question its inequality x squared plus x greater than or equals to 6. To solve the inequality, let's write all sentences in one side of inequality. So we have x squared plus x minus 6 greater than or equals to 0. How we can solve this inequality? What's the meaning? Let's focus on the meaning of this statement. It means that this is a parabola. For which value of x this parabola is above x-axis or has intersection with x-axis. Above x-axis or has intersection with x-axis. So to answer this question, I prefer to find zeros and see if there is any real zero or not. So we set the equation to 0. You can solve it with any method that you want. I want to factor this equation. I'm looking for two constants with multiplication -6 because it's negative. One of them is negative dollar, one is positive, and the addition is positive 1. So it's positive 3 and negative 2. So the two x-intercepts are x equals positive 2 and x equals to negative 3. As you see, they are real zeros. By looking at the equation itself, you see that the parabola opens up because here is positive 1. Now let's sketch the graph of function. Real 0 is negative 3 and positive 2. I don't want to sketch the graph accurately, but its parabola opens up and it passes through these points. 2 and negative 3. Okay, now look at the function. Look at the parabola. For which value of x is above x-axis? This part and this part. For which value of x? For these points. X is greater than 2 or less than negative 3. For which value of x is equals to 0? Here and here. Because when x is negative 3, the parabola is 0. The equation is 0. When x is 2, f of x is 0. So the answer is from negative infinity to negative 3 included, and from 2 to positive infinity, negative 3 and positive 2 are included because the value of function for these 2 points is 0 and they are intersection of function with x-axis. In this question, we are looking for the complex zeros. And we have quadratic function x squared plus 3x plus 8. By looking at the function, you see that it is a parabola that opens up, and if it has complex zero, it means there is no intersection with x-axis. So the graph of function should be something like this. Let's find the complex zero. To find zeros of any function, we set the function to 0. So we have x squared plus 3x plus 8 equals to 0. We cannot factor. The one way to solve this quadratic equation is using a quadratic formula, and another way is to solve the zeros by completing the square method. I want to use the quadratic formula. So what is a, b, and c? A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Recall the quadratic formula here. X is negative b plus and minus square root of b squared minus 4ac divided by 2a. If you replace here, it's negative 3 plus and minus 9 is 3 squared or 9 minus 4 times 1 times 8 is 32 divided by 2. If you simplify, you get negative 3 plus and minus the square root of negative 23 half. The square root of negative 23, you can rewrite it as negative 1 times 23. 23 itself is a prime number. We cannot simplify. But the square root of negative 1 is I in the complex set. So I can write it as negative 3 plus and minus I times square root of 23 and denominator, which is 2. But these two are the complex zeros for this function. We want to sketch the graph of function, but when we have complex zero, they are not x-intercept anymore. So they do not help us to sketch the graph of function more accurately. Let's find y-intercept. Y-intercept is the intersection of the function with the y-axis, means x is 0. What is f of 0? F of 0 is the square of 0 plus 3 times 0 plus 8. So y-intercept is 8. Another thing is vertex. Let's find the vertex of this parabola. It's negative b divided by 2 times a. So it's negative 3 over 2. And then y value is f of negative 3 half. So it's the square of negative 3 half plus 3 times negative 3 half plus 8. If you simplify, you get 23 over 4. Now let's sketch the graph of function by this information. There is no x-intercept, and vertex is negative 3 half. Let's say here is negative 3 half, and here is 23 over 4, which is 5 point something. And y-intercept is 8. So this is y-intercept. And this is the vertex. By having the vertex, now you can consider x equals to negative 3 half as axis of symmetry. And then this is the graph of function. It's a parabola that it should be symmetric and pass through these points. That's all about the quadratic function. In the description of this video, you find a PDF file contain all formula of quadratic and linear function. I hope you got the materials.